In the field of artificial intelligence, the future is quite bright. Microsoft has published a new research paper on Orca, a truly breakthrough AI model. What makes Orca unique? It picks up lessons from the intricate description of GPT-4, which is now the most effective language model in use worldwide. Let's explore the reasons why this is such a paradigm shift. Microsoft has been gradually integrating AI capabilities into its products and services while also creating more compact, use case-specific models in collaboration with OpenAI. Orca is a new AI model from Microsoft Research that mimics big language model to learn. Orca is intended to circumvent the limits of smaller models by replicating the thought processes of big foundation models like GPT-4, claims the research article. Large language models like GPT-4 can be used to train language models like Orca, which can then be tailored for certain tasks. Orca uses less computational power to run and function because it's smaller. Without relying on a sizable data center, researchers can independently run and optimize their models based on their needs. The study report claims that Orca, an AI model fueled by 13 billion parameters, can replicate and learn from complex language models like GPT-4 and is built on Vicuña. With the aid of GPT-4, which is said to have more than 1 trillion parameters, it can learn explanations, step-by-step cognitive processes, and other complex instructions. With Orca, which has already outperformed Vicuña by 100% on challenging zero-shot reasoning benchmarks like Big Bench Hard, BBH, Microsoft is promoting progressive learning through the use of extensive and varied imitation data. Additionally, according to Agibil, the new model is 42% faster than traditional AI models. Orca is reported to be on par with ChatGPT in terms of reasoning, despite being a smaller model on tests like BBH. Additionally, through its trials, GPT-4, it exhibits competitive performance on academic exams like the SAT, LSAT, GRE, and GMAT. According to the Microsoft research team, Orca can learn using detailed explanations written by people and increasingly sophisticated language models, and it's anticipated that it'll gain better skills and capacities. Why would we need a smaller device like Orca if larger ones like the GPT-4 are so potent, you might be wondering? Well, the truth is that larger models have unique difficulties. They not only cost a lot to operate and train, but they also consume a lot of computing power. They are frequently out of reach for the majority of researchers and developers because of its restrictions. Due to these restrictions, there is an increasing interest in creating more compact, more effective models that are nevertheless excellent at a variety of tasks, like answering questions, summarizing text, and creating captions. These smaller models frequently focus on particular datasets or instructions to increase their efficiency and specialization. But this has its own set of problems that must be addressed in order to meet the limitations of smaller AI. The difficulty with smaller models is that they frequently have lower thinking and comprehension capacities than larger counterparts. They frequently make mistakes or provide irrelevant event answers when faced with difficult or unclear questions. Furthermore, these models are unable to provide a justification for their conclusions or a breakdown of the procedures they took to get there. Orca excels in this area since it isn't just another smaller model attempting to mimic a larger one. Orca's approach to learning is distinctive. It gains knowledge from the complex GPT-4 explanation trials. It gradually assimilates the specifics of how GPT-4 functions and thinks. It investigates how GPT-4 uses reason and common sense, connects various pieces of knowledge, and simplifies difficult topics into easier-to-understand ideas. By learning from these explanations, Orca develops to be significantly more capable and clever than other comparable models. It can now handle a larger range of difficult jobs, produce more accurate and relevant results, and, most crucially, it can now explain its own thought process to us humans. In the field of artificial intelligence, we're on the verge of a new age. It's time when groundbreaking models like Orca are ready to go open source, lowering access barriers and releasing great potential for development and innovation. Orca will soon be accessible to everyone, democratizing access to potent language models. The change will enable more individuals to take advantage of GPT-4 capabilities without having to pay hefty fees or wrestle with its restrictions, and it goes beyond just being convenient and inexpensive. The emergence of new chances for AI research and development, particularly in fields that need sophisticated understanding and reasoning abilities, will be sparked by the open sourcing of Orca. GPT-4 is not just an advanced text generator. It's an AI powerhouse capable of performing reasoning-intensive tasks like summarizing lengthy text, creating subtitles, composing essays, and many other things. However, GPT-4's capacity to explain its results is what makes it special. These are located in the model's internal states, which are effectively its thoughts and memories, and contains the reasoning and data needed to produce the desired outputs when given the appropriate cues. These internal justifications can be revealed giving through an understanding of how GPT-4 thinks, solves issues, and draws knowledge from a variety of sources, including its own memory, the internet, and common sense. For smaller models like Orca, these explanations are a goldmine of learning opportunities, providing additional clues and direction on how to carry out different activities and think critically and understand diverse concepts. They also improve clarity and human interpretability of the learning process. Orca makes use of this. It gains knowledge from the justifications that GPT-4 produces as it completes various tasks. Orca learns from these explanations and tries to replicate them as accurately as it can. Even more interesting is the fact that Orca uses comparable challenges as an opportunity to compare its own explanations to GPT-4's explanation in an effort to become better. By providing a novel method called explaining tuning, which enables it to learn from the intricate explanation, Orca expands on the Vicuña foundation. Explaining tuning is a cutting-edge method that enhances GPT-4's capacity to adhere to detailed instructions by adhering to hints like summarizing this in a phrase. Although explaining tuning takes a step further, GPT-4 can be trained to become more effective at particular activities. GPT-4 may also be trained to reveal its thought process by responding to suggestions like think sequentially or explain like a child. This procedure increases the clarity of GPT-4's logic. Two different sorts of prompts, standard and explanation, are used in this strategy. Tasks like writing a writer poem or identifying the leader of France are common prompts. Explanation prompts such as think in steps or show how you did it are used in tandem with Struct GPT-4 to elucidate the rationale. These questions stimulate the creation of intricate explanation traces by GPT-4 that addresses the subject at hand and highlights the approach to problem solving and the sources of information used. In order to test GPT-4's capacity for reasoning, it also creates challenging prompts from this dataset, such as combining two tasks into a single one. Orca exposes itself to a wide variety of complex and varied tasks, developing a wide range of cognitive abilities related to human intelligence. The effectiveness of Orca is systematically evaluated by a series of standards that rate its capacity for generative thinking and comprehension. Among these benchmarks are multiple-choice tests, natural language interfaces, text summarizations, text generation for picture captioning, and more. Orca isn't only assessed on its own, it also is measured against other models of its similar size or greater. There are various insights into the future of artificial intelligence provided by the success of Orca and the future of AI. First of all, it exhibits the enormous possibilities of learning via explanations rather than just straight answers. More than just improving performance, Orca's approach to analyzing GPT-4's explanations provides a window into its thought process and the capacity to give transparent account of its problem-solving techniques' viewpoints. Orca is a revolutionary force in the field of artificial intelligence and rejects the ideas of an AI model's effectiveness and primarily determined by its size, although on a smaller scale. By taking lessons from GPT-4, Orca equals or even outperforms the performance of larger models. This avoids the problems of large-scale AI models, particularly the requirements for a lot of resources and energy, and produces a more usable, effective model. Last but not least, the impending open-source release of Orca conveys a strong message about the revolutionary potential of open-source AI by using creative learning. From GPT-4, Orca reaches a level of performance comparable to that of proprietary AI models. In addition, Orca serves as an example of how open-source AI's wider accessibility can spark a variety of uses and advantages for a larger audience. In conclusion, Orca holds a special place in the field of artificial intelligence because it expertly combines the strength of GPT-4 with the usability of open-source AI, demonstrating the enormous potential of explanation-based learning. The development of AI could benefit from Orca's success, especially in terms of fostering openness, effectiveness, and general accessibility.